You can, once the carbon dioxide is coming as a dry ice at minus 78.5 degrees Celsius, then the remaining components will pass us through this pipe, and here they have been made a expansion jet to increase the force of flow of these liquid gases. So the pressure will much increases. You can see here they are using a jet expansion jet where it will be compressed so that the liquid gases will move very fastly and they will enter into the column called as, what is this column called as?
Fractional distillation column.
Distillation column. Now, this fractional distillation column will work with the phenomena called as what? What is the phenomena? What is the phenomena of fractional distillation? Principal
evaporation and condensation.
Evaporation phenomenon.
Followed by condensation.
Evaporation followed by condensation. So, that is what it will happen. So whenever the carbon dioxide will releases, then it's a further cooling you can see. Then here at minus 183 degrees Celsius. So what will happen? Which will separate first? Minus 183 degrees Celsius.
Oxygen.
Oxygen will separate, and these oxygen we will collecting in a separate beaker as it is. What is the beaker called as? Liquid oxygen. Have you noticed it here? The liquid oxygen it is coming at the bottom of the container, so that we are separating in the separately we are collecting and we are storing as a liquid oxygen, and these liquid oxygen only we are using to patients and all hospitals patients. We can use this one, those who are having a breathing difficulty, and as well as we are using in manufacturing steel in industries. And same way, next height, the oxygen separate out, remaining gases will go down. After that, what temperature will come? Minus
186.
186 will come. Understanding? Very less. So minus 186 will come. So at minus 186 degrees Celsius, which gas will separate?
Argon.
Argon will separate. And these argon will store in the separate container. Next, the temperature will reach us to what? Minus 196. Understand? So minus 196 will reach us. So by the time what gas will collect?
Nitrogen
gas will collect, and it will be stored separately, and it will be used to manufacture fertilizers. So this is what the complete process of separation of components of air. Now let us watch the video, how it will be and how it is separated and all. Now you can understand what is happening exactly inside the process. Shall we start now? Everybody? You can note very carefully. This is a very beautiful video which you can understand very clearly. So this is what the process of separation of components of air.
Separation of components in air. Air is a mixture of several gases, and these can be separated by fractional distillation. This is brought about.
Understand everybody here? Once the air is filtered, when it is sent it to the compressor, it will turn into hot. That is why the hot air they are indicating with the what color? What color?
Compressing.
Red color.
Red color. Normally air will be in a what? Normal, it is a colorless. Now that is why they are representing with the what? White color. But if the same air is compressed, it will turn into hot because temperature increases or decreases? Temperature increases or decreases? Yes, please. Temperature increases. That is why it will turn into hot. Now, the same air we are passing through a cooler, understanding, where it will be rapid expansion so that fastly the temperature will fall. So you can see how it will be happening.
And
that is why you can see after cooling, the air is representing with the what color? After cooling, the air is representing with the what color? Yes, please.
Blue color.
Blue color, because it is liquefied air. That is why liquefied air is a cooled air. So that we are representing with what color? Blue color. Okay. Now you can see how it will be
of
taking
air
place.
and allowing it to slowly warm up in
Inside that ring, something is passing. What is that? Anybody? A freezed water, understand? A very coolant water where it can absorb the temperature from the hot air and will make it for rapid expansion and for sudden fall in temperature, so that it will convert it into liquefied air. That is the reason we are using this coolant in the middle.
a fractionating column. Air is first passed through a filter to remove impurities like dust particles. Filtered air is passed through compressors and it is compressed to very high pressures around 200 atmospheres.
What is the pressure
Compress-
they said? What is the pressure? Harish, note down the value. What is the pressure they said? 200 atmosphere, 200 ATMs. Understand? That is what, imagine that.
Air is passed through a freezing unit where it is cooled to about minus 200 degrees centigrade.
So what is the temperature it is cooled? What is the temperature it is cooled? Minus 200 degrees Celsius. Minus 200 degrees Celsius. That is what? So minus 200 after minus 199. Next what will come? Minus. What will come next?
Minus 196.
That is what? Okay. So it.
The cooled and compressed air passes through a separator when carbon dioxide gas solidifies and is separated as dry ice. The air which is now free from carbon dioxide is forced through an expansion jet where it liquefies. This liquid air is allowed to slowly warm up in a fractionating column. Nitrogen first boils at minus 196 degrees centigrade and is separated.
Then
The
who is the
argon,
second?
which boils
First nitrogen. Who is the second?
Argon, sir.
Argon. And the third one is oxygen. So that is what? So what is the use of expansion jet? It will increase the rapid cooling again. It will increase the force and as well as rapid cooling, so that again warm up will take place. Where the warm up will take place again? Fractionating column. Okay, so cooling and again heating, cooling and heating, that is what will take place. So fractionating column, it will again warm up, so that what will happen? The temperature will keep on increases, minus 196, minus 183, minus 180, like the temperature rising. That is what you have to remember.
at minus 186 degrees centigrade is collected. Oxygen, which has a higher boiling point, is left behind and is collected separately.
Have you understand, everybody? Yes,
Yes,
please.
sir.
So that is what will happen. So who is having high boiling point? Who is having high boiling point? Who is having high boiling point? Yes, please.
Oxygen.
Oxygen. Low boiling point is nitrogen. You can see here how it will be. Liquefaction of air. They are showing like industrial process. It is passing through that. And here what will happen? Hot air is passing, so it is rapid cooling. Compressor, it is compressing. Compressed by increasing the pressure. So they will compress the air so that all the air particles will come closer. So pressure is increases to what pressure? 200 ATMs. Understand? Then it will be converting into hot air. Now this one, they are passing through the cooling agents. So that is what a cooling area. So where it will be liquefied by rapid expansion. That is what it is. You can see the freezing cold water inside the pipe. So that hot water will compress it. It will be compressed cold water. It will turn into cold air. It will be. So that is what is the process. Have you understand? Hope everybody understand what is the process taking place. So this is how we people will separate what is the. One minute. Have you understand or not? So that is what the process which will take place in cooling, and as well as again we people will warm up, so that how the components of air, everything will be separating out from the air. So all the components of air based upon their boiling point difference, which we people are, first we are compressing to increase the pressure, later we are going for rapid cooling, and later again we are slightly warm up, so that we are going to get all the nitrogen, oxygen, and as well as what? Argon separately, which we are having multiple uses. Now, the present days, whatever the cylinders we are using, oxygen cylinders, when we are climbing the mountains and all, trekking and all, and as well as inside sky water diving and all, everywhere the cylinders, whatever the oxygen cylinder, if you go to hospital, you all people will see the oxygen cylinders. Yes or no? Yes, please.
Yes.
So that all the oxygen cylinders, everything, they have been separated the oxygen from the air with this process only. And this process is only we are using in even industry to separate the components of nitrogen, argon, and as well as oxygen. But that boiling points is very, very important. So very simple process. Compression, later it will be rapid expansion so that it will be cooling. So liquefied air will come. Liquefied air again will allow for little warm up in which column? Fractional distillation column. So that nitrogen boils first, oxygen next, argon boils second, and something is left behind at the bottom of the fractional distillation. That is only we used to call as, what is that? Oxygen. So that is what it is, the boils third, because it is having highest boiling point, and this is the lowest boiling point. And what is the carbon dioxide boiling point? 78.6 Celsius. So it will be before itself it will be separated in the form of what? Separated by in the form of dry ice. That is what you have to remember. So this is what about this. I hope everybody understand. So this is all about the things which is present in this chapter. Now I will give you the big exercise related to this also, and also tomorrow if we will practice all the exercise questions and all in our class itself, because as if I am giving to you, you people are not studying. So once it is over, then we will move to the third chapter in physics. That is what it is, gravitation. Now whenever you are free, we already studied the physical changes, chemical changes, metals, non-metals, and filtration techniques, everything. What is the elements, what is compounds, and what is the difference between them? As we studied or not already? Yes? Please? So that all the techniques, everything, whatever we studied, everything, please kindly once again you remember the properties of sulfur and iron mixtures, that all the mixtures, components, everything. So anything doubt you can ask me. So this is what about this chapter. So there is nothing important things in this. All are very theoretical only, but all the processes are very, very important for even your competitive exams also. Even government exams also, they will ask you which separation technique we can use it for a given component, a given mixture. So by that time, we have to be very, very careful. Either it is a miscible or immiscible, or is a solid is dissolved in liquid, or liquid is dissolved in liquid, or gas is dissolved in liquid, and all the properties of suspensors, solutions, colloids, everything we must have some idea. Then only it is possible to answer. That is why, as it is every government exam, I am saying you remember again, from 9 to 6 to 10th CBSE is compulsory. So the main thing, all should learn like these things, more to know. You might be noticed, I already discussed this also in our class. So as we know, till now only the one metal is in liquid state. What is that metal liquid state? What is the metal liquid state? Mercury. But the metals like gallium, cesium, and 7 more metals, they are also almost they become in liquid state, because now atmospheric temperature is increases already. And if you take this gallium and cesium, even if you hold it in your hand, they'll become into which state? They'll become into which state? Liquid state, because their boiling point is just slightly above from the room temperature. That is why they can easily melt, even the temperature rises very small. So that is why like these things, you all people learn very, very useful in your future. All the competitive exams, national level Olympiads, all the things, like these things only the people will touch. So learn everything, whatever it is, and all the things in this chapter we discussed. Is there anything left, Mitakshri? Harish?
No, sir.
No. So please learn once again. And my sincere suggestion for you all, remember, read the text. NCRT. Don't depend on guides. I never prefer the guides. Read NCRT line to line. Everything we discussed in the chapter, whatever important we studied, please learn. And once it is over, tomorrow we'll discuss the exercise of this chapter. Once it is over, then we'll move to the gravitation chapter. As it is gravitation, for foundation, it is very, very important. It will take more days to study. So we'll discuss that and we'll make it. Okay. So thank you, everybody. We'll meet in the tomorrow's class.
Thank you, sir.
Thank you, sir.